So safe operation and our safe KUKA option packages consist of a couple of different programs. One is safe operation, which includes safe range monitoring, safe single break, safe velocity monitoring, and our diagnosis safety. Now you can get these separately as well. And so we're going to start with a product overview, value, and details and features of safe operation. Back in 2005, KUKA released its first safe robot, also on KSS 5.1. And through the years, we've released a bunch of different features. We started off with 3 safe tools, 8 safe areas. We then got our discrete wiring, which includes our X13. Now we're up to 16 safe tools and safe monitoring areas, safe single break. We can simulate a stop zero and obviously incorporate digital safety controllers. Some of the best features of safe operation are both cost effective and include making your footprint smaller. So when you look at your safety gates and things like that, you can eliminate that with safe operation due to it being virtual. You can customize it to how you need, how you want, whether you need one giant cell or if you need a protected space or a workspace that can all go through higher level controllers, safety controllers, or directly through the KRC 4 or 5 controller. Any questions so far?
Nope, not yet.
Okay, I'll keep going. So one way to incorporate safe operation is through manual loading stations or even welding cells. We can use safe single break to essentially put a positioner with the welding cell. As the robot works along one side of the positioner, a operator can also work on the other side of the positioner, whether it's loading a part, taking out a part, whatever the case may be, we can go ahead and do that. So this is just an example of a manual loading station with safe operation. Here, you have your light curtains, safety gates, and things like that. With safe operation, you can kind of eliminate those things. You have your safe tool enabled, where you can put in a part, take it out without having to completely cut off power to your access drives. You can use a safe operational stop, hit the button, access will stop. You put your part in or take it out, hit the stop again, the robot will continuously move, and that decreases your cycle times. So in terms of floor reduction and floor space, we have both Cartesian and axis monitoring. So if you don't want your robot to move to a certain spot or anything like that, you can say, okay, I want axis 1 to only go positive 90 degrees to negative 90 degrees. And outside of that, the robot shouldn't move. It should stop and throw an error. Which means you can have more space for different things, whether it's more robots, more operators, wherever the case may be. It helps you customize your cell to what you need it to be. And so this is the example of a fenceless application. It's a palletizing application where we have a safe scanner, a safe PLC, and as a human approaches, the robot slows down. So this could be used if you need one side of the palletizer is full, the other side you need to put more product on, and the other side, the operator can go ahead, remove that pallet, put a new one in there, and still be qualified as a safe robot. And so some of the biggest features with this is that, some people may want to use a cobot in this situation, but you're limited to a couple of things with a cobot. You're limited to cobot speeds, and you don't have as much as flexibility as you would with an industrial robot using safe operation. And so this is just the workspace and how essentially this application would work. Any questions so far?
Nope.
Okay. So now we're going to go into the compatibility, safety interfaces, in the product segmentation in terms of each individual KOP option. So safe op, safe single break, all our safe products work with both KRC4 and KRC5. It also works with the full range of robots, with some exceptions like the Deltas and KR4s and SCARAs. They do have their own safe options, but not the full range, which I'll get into in a little bit here. One thing to note, with the KRC5, safe operation isn't available unless you use the KRC5 micro cabinet. So this is the robot product line and kind of gives an explanation on what is compatible with what software and what robot. And so for the most part, safe operation is geared more towards the 6-axis robots. That's why from the Agilis on, everything's fully compatible and will work. And so we have here the KRC4, the interfaces work with ProfiSafe, SIP Safety, Failsafe, EasyCAD, and our own integrated X11, X13. The Safe Op, you get the full range, 8 digital safety bits. With our integrated X13, you get 5 sensors hardwired. Our X42 is the reference switch. What that does is when you start the robot up, it'll go to that point, say, okay, I know where I'm at in space. It also means cell configuration is valid where it's at. And so essentially it's the same thing with the KRC5, no different. Only big difference is instead of X11 and X13, it's XG11 and XG13. Same with the reference switch, it's XG42. But they essentially work exactly the same, no differences here. And this is the KRC5 Micro. As you see at the top, this is the cabinet. And below is where the interface boards will go. For the X13 for Safe Op to work properly. You also still have your device plate where you can have your field bus couplers and any other sort of things you might need. And then this is a breakdown of the abilities of all the software packages. They all work with safety PLCs, and as you see, SafeOperation has the whole list of features and even some added. Safe range monitoring, you have the brake before restricted area. The safe single brake has the safe operational stop, safe velocity monitoring, Cartesian and axis specific spaces. So are there any questions so far?
Yeah, there's one question. So Martin wants to know what limitation or settings in SafeOperation are required to be applied to securely use the robot next to a human operator.
Yeah, so that you would need your workspace, your protected workspace, and also the safety cell. So we'll get that a little bit later, but essentially you create the cell and the robot from them, once it's activated, will say, okay, I know where the cell is at, whether you have it each space switched on or off as the human approaches. The robot will know, okay, I can't go here. If I do try to violate this, I'll stop, slow down.
And then there was a second part to the question, and it said velocity limitation is sufficient or other measures are required.
So you're asking if just having the velocity range of the velocity monitoring on, if that'll be good enough to work with a human?
Yeah, or like are other measurements required? And this was the same. This was tied in with the same question as the last one as well.
Yes, yes. So you would need SafeOperation. That way you'd have the ability to the braking before restricted area. That's an important piece of that. And also the Cartesian spaces and axis spaces that you may want to set up for that application. So you would need SafeOperation. And if you had that, you'd be able to do what you're requesting.
Okay. There's a couple more questions. This one says, what is the process for setting up the inputs for letting the robot to move like X11?
Yeah. So if you're going to use our integrated X11, it's just a simple pinout. I can get you that information after the webinar that shows the pinouts and how you just need to plug them in.
Okay. And then this one says, human interaction with robot is qualified as Cat 4 of safety requirements per IEC 61496 ISO. Our safety operation is approved solution by ISO.
That I'm not 100% positive on. I can get that information to you though.
Okay. I think, yeah, that's it for now. So we'll continue on, and any more questions, we'll wait.
Okay. So that leads us to safe range monitoring. This just gives more of a breakdown of that specific package, which includes braking before restricted area, having your user defined access spaces, and with X13, since it's hardwired, it only gives you 6 versus the whole 16. And once again, this applies to anything safe operation, safe range monitoring, all of them in general. Work with a higher level PLC. You also get your status messages. All these are pretty standard. And then safe single brake. Safe single brake. Most people like to use this, like I was saying, with the welding cell. You have external axis, robots working on one side, operators working on the other. You can have a stop, operator pushes, that axis will stop, the robot will keep moving. With X13 though, you don't get the status messages, once again, just because it's hardwired. With this as well, you get the 6 axis groups, 8 total. You can define them how you want. It's all about how you want your cell. Next, safe velocity monitoring. This goes back to defensive application where you can have the robot slow down as you need when it comes to your cell, your protected spaces, or even your workspaces. Maybe you need to have it nice and slow as you put the part in, whatever your application may be. This is the one safe application that does work with KR4 and the SCARA. And then SafeOp has everything that the previous packages had and more. You get your 16 axis specific or Cartesian spaces, up to 5 with X13. Your BB breaking before restricted area. You even get your safe tools with X13. You only have 1 active, but you can create a safe tool with 12 spheres, up to 12 spheres, 96 total. And so, are there any more questions so far?
Yep. One more came up. It says, with the SSB, can you stop each brake of the robot one by one also? Or the A1, A3 axis group and A3, A6 axis group limitation is still there?
Yeah, you can actually do both. If you want to have a group where you do A1, A2, and A3 with one safe op stop, you can do that, or you can have it where it just stops on one axis.
All right, I think that's it for questions for that section.
Okay. Okay, so we're going to go more in detail with the safe operation technologies. And the big part here will be the breaking before restricted area. So one of the benefits of safe operation is creating your cell how you want. You can have from 3 to 10 corners. If you need an octagon, square, rectangle, however big you need it, you can create it. You can do it whether it's work visual in KUKA Sim or right on the Teach Pendant. This also includes your safe tools, spheres, limits, and things like that. So axis-specific monitoring ranges, this goes back to we can have the robot, whether it's A1, A6, any axis, we can say the degree we want it to move and essentially make a monitoring space just from those different axis movements. With this, safe single brake and braking before restricted access, you can have the robot slow down, stop on the dime for the most part, however you need to do it. And having it stop from a higher level controller gives you that stopping distance becomes shorter. So this is just an example here of the Cartesian protected workspaces. So if you see on the right, you have the green and the red. The green is the workspace where your robot can move freely, do its application, and below we have the protected workspace, or protected space, I'm sorry, where the robot won't go. If it is violated, will stop, throw an error, and let the operator know. These workspaces can also be activated through different safe inputs. So for instance, if you have a robot on a linear slide, your monitoring spaces, Cartesian monitoring spaces, will follow the robot at Rob root. Now, if you have maybe robots going to different spaces, you can create that as well. If you have one space that, as the robot's traveling, is a rectangle, the next one's a square, the next one's, an octagon. However you have your workspaces, the robot will know and will follow that. And so here, it's just more in-depth showcasing of the safe tools. You have your spheres. You can have them as big as you want them. Like I said, up to 12. It's all about detail and defining what that tool is and making it as safe as possible. This leads us into braking before restricted areas. So the best thing about braking before restricted area is that when this is activated and you have your monitoring spaces activated, it already knows where it's at. So if it knows it's about to violate a space, it'll start to slow down. It's a much more controlled stop instead of, oh, I reached the end of the cell, I'm gonna do a hard stop. And over time, that can obviously negatively affect the robot. This way, it doesn't do as much harm. And the best way to say that is in stop 0 and stop 1. Stop 0 is the hard stop. Stop 1 is the drive ramp stop, whereas it's a more controlled, slow down stop. So diagnostic safety, this is standard with all robot controllers, even if you don't have safe operation. It'll detail the controller interface boards and system interface boards on the controllers, let you know if your inputs are working, which has all the variables, and also showcases your work cell. Any questions so far?
Yeah. This one says, how can we determine what speed is needed for reduced speed to achieve a limited stop distance? Example, if we only have 500 millimeter distance to a light curtain, how can we know what speed we can run at safely to make sure the robot stops in time if someone breaks the light curtain?
Yeah, so there's a couple ways you can do that. Now, 500 millimeters isn't too much space, and so the robot does need energy to stop. So the best way to kind of do that is if you can create your cell and then have it where it says, okay, in this area, if I'm within 200 millimeters of this area, I'll start to slow down. If not, just stop. So what I'm just trying to say is that when the light curtain is broken and the robot says, okay, this has been violated, the robot will come to a slow stop and then a hard stop. So I can't give necessarily a direct answer on, the speed, but just more of the layout of the cell.
Alrighty. Another question. Is a safe tool monitored against collision with the robot arm itself, and can it be configured?
So you can configure it that way. So if you want the safe tool to, if you want to put a sphere around, let's say 3, that's, and have also, 2-3 spheres on the tool itself, so that if for some reason you have a cell where you're concerned that maybe one of the axes might hit something, that sphere basically represents a safe tool around that axis.
I think that's it for questions for right now, so you can continue.
Okay. Also with this, another feature, if I didn't already say it, was showing the safety cell as well. So now some of the parameters, the workspace variable, when you have this on, the braking before restricted area sees that and says, okay, I'm gonna slow down or react how I need to when it comes to that space. And so this is just an example of the robot is on a path to a workspace, an activated workspace, and what some of the results will be. So there's a few scenarios that we'll run through here to kind of showcase what the robot will do. So with this scenario, we have the robot approaching this box here with both the workspace off and braking before restricted area off. And you see with both, the robot knows that's a restricted area and did a hard stop once it violated that space. And that's with, like I said, with both of these off. Same situation, but we have the workspace turned on. And so with that, once that space was violated, the robot stopped instead of going through a little bit more. So that stopping distance increases, well, decreases, I should say. Again, same situation, but instead we're going to have the braking before restricted access turned on, but the workspace turned off. And so it's very important to note with braking restricted access or area, I'm sorry, the stopping distance becomes smaller and smaller. It still may violate that space, but it's slowing down before it gets there. And so the last scenario is having both of them on at the same time. And so we can see here with both of them on, the robot recognizes that space, slows down before it gets there, and doesn't touch it. And so having both of these on at the same time reduces the stopping distance significantly, reduces the speed, and is much less likely to violate any spaces. And so this is basically a breakdown of the scenarios we just saw, and also kind of incorporating switch spaces, showing whether you have the safe tool, your protected space, safe single break, what will it do? What will the robot do in those different scenarios, and how it will react? And so these are a couple more scenarios, but with this, we're doing switch spaces. So using the fenceless palletizing application that we saw earlier, if an operator has to remove a full pallet, put a new one in, whether it's the controller or higher level safety controller is letting you know, hey, we're switching the space on and switching another space off. Here's a couple scenarios of how that would look, with first having that protected space off and that breaking before restricted area off. Go straight through the protected space, full speed. Then with the second scenario, we'll have the protected space active, but that breaking before restricted area off. So the robot violates that protected space and stops. And once it does that, you can see that that stopping distance is decreasing instead of going straight through. Same scenario, but we just have both on at this time. And so once again, you can see the robot slowing down before it reaches that space and stopping before it violates it. Okay, any questions so far?
Since the last one, let me double check.
Okay.
Yep. One came in. It says, what safety ops sensors are utilized? KUKA or third-party machine vision cameras, radar, sonar?
You can use a mixture of both. So once again, just like I said with the safety scanner and the palletizing, the scanner realizes someone's coming closer to the robot. It tells the robot, hey, slow down, stop. A human or operator is coming into that space. So you can use a mixture of both.
Okay, you're good to continue on. There's no more questions as of right now.
Okay. And so this next segment is more with KUKA.Sim, how you can create your cells, and a couple of examples of what that looks like. And so here I've got a video of a cell. And so what I'm going to do is play it, and this first run through is what the cell is going to do with no safety options enabled. Just a simple pick and place. Product goes down to the operator. He does what he needs to do with it. And then the robot wants to give him a high five after. So now, next, we're going to turn on our workspaces and our danger spaces. We've enabled the safe monitoring. And we also have our safe tools configured. So the robot is good to go to work in that workspace there. And as it comes towards the operator in that cell, that protected space, it slows down and stops. So now turning off the protected space so the robot can go through the protected space at this point. But what it's showcasing is the access specific limits. And you should see that in the back, the red box should not be able to be picked up simply because we've enabled it not to go past negative 80 degrees and 100 degrees on A1. And it just does just that and stops. And so now the last configuration here is having everything turned off except for the safety cell, our overall cell. So the robot should be able to do everything, pick up all the boxes. But with the safe tool on and active, as it's trying to give the human a high five, it says, no, I can't violate that space, and slows down and stops before it even reaches it. Okay. And then one of the great features of KUKA.Sim, Work Visual, and the controller itself is that you can do this all here on KUKA.Sim and export it to whether it's Work Visual or the controller. So instead of doing it on the Teach Minute, you can do it here in KUKA.Sim. You can visualize it, rotate, look, and choose which robot you need. Once you get your cells set up, you can just export this whole project directly to Work Visual, deploy it to the controller, and you'll be good to go to start your project and do any programming you might need to do. So we're going to export the project here. We're going to browse for the project in Work Visual. So whether it's locally or if you're connected directly to the controller, or if you want to access the controller, via a network IP, you can do that too. So here I also like to check to make sure my bus structures, everything that's on the controller matches what I have in Work Visual. Same for the KRC config. We want to make sure that it's updated to the current and latest and greatest that's on the controller. We don't want anything different to push to the controller that's not already there. From there, we generate the code, deploy it to the controller. When deploying any safe operation KOPs to a controller, you want to make sure you're logged in at the very least as a safety recovery technician. And now the project is now active on the controller, and you're all good to go to do any points or movements with your robot. We can also look at the safety configuration, make sure everything matches and looks good. We've got our monitoring spaces. Our access monitoring, and our safe tools. Everything that we did in SIM is right here on the controller. Okay. Now here's the safety diagnosis, which you can see on the Teach Pendant controller as well. So now we can see, move, do everything we need to do on the Teach Pendant. If we need to make some corrections or anything like that, maybe your computer's not next to you, you can still see the safety cell, see everything that you did, your workspaces, access monitoring, and your variables for your safe spaces, ranges, everything is here. You can test it to make sure, hey, I know this is working. I know this is here, and things like that. And so that's the end of the webinar. Are there any other questions?
Yeah. This one says, can a safety operations workspace be designed in a field deployable environment for construction zone high beam welding on a crane boom, JLG, or genie lift?
So if you mean having the safety cell, say, creating it where there's a certain height that maybe you don't want the robot to reach to because you have cranes and things like that, but it can't be applied to cranes or anything outside of a KUKA robot and controller.
Looks like that's it.
Okay. Well, thanks everyone for joining. I appreciate it. If you have any questions, feel free to reach out.
Industrial intelligence.